Welcome to Lesson 2. This is Chapter 2, Lesson 2, Tolbert's class. Chapter 2, Lesson 2. A couple of the objectives. To review the atomic basics. So I hope that you're going to be able to draw, place, and locate the different parts of the atom on a corresponding worksheet that I believe is on page 18. You're going to listen and watch about water, the characteristics of water. However, if you're listening to this recording, you won't be able to watch that video. I hope you're able to look up and find the characteristics of water on your own. We also define the characteristics of water and that of solutions. The current sheet that you're looking at is Chapter 2 of this Atomic Basics is on page 18. Here we are. This is what that looks like. So we're basically going to just simply follow the instructions. And the first instructions that ask you to draw 5 protons and label them with their charge, 6 neutrons. So I'm just going to label charge here. So 5 pluses, 1, 2, 3, 4, 5. And zeros are going to be my neutrons. So do that now. Then we're going to do the next things, which is 2 electrons on the first energy level. Boom. And 3 on the outside. There they are. The element represented in this particular one is called boron. We're going to name these different fields here. This first arrow is pointing to the atomic number. The next one is the symbol, followed by the name and the atomic mass. The atomic number represents the number of protons. It also represents, for a balanced one, the number of electrons. The atomic mass is the combination of protons and neutrons. How would you figure the number of protons or electrons? I would simply look at the atomic number. In order to find neutrons, I would take atomic mass minus the atomic number. Gives me my neutrons. And the next thing that we'll have to fill out is this one here. The number of protons for sulfur is 16. The number of neutrons or electrons is 16. And we have 16 neutrons. The Bohr diagram shows all electrons, 2 on the first, 8 on the second, and the rest go on the third. Lewis dot structure would get the total electrons on the outside. The first energy level can hold 2 electrons. The second energy level can hold 8 electrons. The third energy level can hold 8. This are called valence electrons. That is it for this particular. No, there is more to this recording. Let me go ahead and clear out this form first. The water molecule is a polar molecule. One end is slightly negative, while the other end is slightly positive. That characteristic leads us to water being polar, because the negative end is attracted to the positive end here. This is what we call a hydrogen bond. That hydrogen bond makes water very cohesive or sticky. Cohesion is the attraction between molecules of the same substance. It pulls water molecules together. This leads to surface tension. Adhesion helps draw water out of the roots of the plant up to the stems of the leaves. So this is how water gets from the ground up to the top of trees. Adhesion is the attraction between molecules of different substances. Water has a high heat capacity. It allows large bodies of waters, lakes, and oceans to absorb large amounts of energy without large changes in temperature. Heat capacity is the amount of heat energy needed to increase a substance temperature. A solution. A solution is an intimate mixture of two or more substances. The word intimate means that one kind of molecule is mixed together in direct contact with another kind of molecule. Because of this intimate mixing, solutions are said to be homogeneous, but this is not always. If a crystal of table salt is placed in water, sodium chloride ions on the surface of it are attracted to the polar water molecules. These substances that have attraction to water are known as hydrophilic. Hydro meaning water, philic meaning loving, water loving. Ions break away from the crystal that are surrounded by the water molecules. These ions gradually become more dispersed in the water, forming a mixture called a solution. This is what happens when something is being dissolved. It looks like the salt is disappearing, but actually what's happening is all the sodium and the chlorine are getting pulled apart and evenly distributed around the container. You need to know a solute in salt water solution. Table salt is the solute. That's the stuff you stick in the water, the substance that is being dissolved. Water is the solvent. It's also known as the universal solvent. Thank you for listening today.